Alright, hello again. In this homework / tutorial, I'm going to ask you to draw the molecular orbital system for ethylene. Ethylene is C2H4, so there's two carbons double bonded to one another. Each one of those is then bonded to two other H's. So go ahead, hit pause, and work out the molecular orbitals for ethylene and then come back. Okay, first thing you should have done is identify the hybridization of those two carbons. So each carbon has one double bond. It's bonded to three things. So a carbon that has one double bond, it's bonded to three things, is an sp2 hybrid carbon. Alright, so let's see how we get to that. So from the valence shell of carbon we have the 2s orbital plus 3 2p orbitals. This is going to give us, if we do sp2 hybrid orbitals, we'll get 3 times sp2, and that's going to leave 1 p left over, right? So if 2 of the 2p orbitals mix with the 1 2s orbital, we'll have 1 p left. It's a way to logically think about it. It doesn't quite work out that way in reality, but it's a good way to think about it. Okay, so we've got 2 sp2 hybrid carbons. What's the shape of an sp2 hybrid atom? Well, as you can see, it's bonded to three things, so you should immediately know that it's trigonal planar. That's a G. And that's basically just something you have to memorize. You can work it out sort of by logic. The easiest way to arrange three objects around one object is in a plane. That keeps those groups as far away from each other as possible. Alright, so let's do that. Let's put the two carbons in carbon, carbon, and I'm going to draw in red the 2p orbitals. I'm going to draw, actually, they're planar, remember. All 6 atoms in ethylene are in the same plane. So I'm actually going to draw 2 of the sp2 orbitals, one coming out at us, one going back away with the dash and wedge you're used to from stereochemistry, and then the sp2, the third one in the plane of, or yeah, sort of in the plane of the board. All right, both carbons are sp2 hybridized. So there's, roughly speaking, the sp2 system. And again, all of these are supposed to be, I've canted it just a little bit at you, but it really is supposed to be exactly in the plane, perpendicular to the plane of the board. Then the hydrogen atoms wind up at the end of those. The hydrogen atoms just have a 1s orbital. They can only ever make a sigma bond. That sigma bond is formed by the overlap of the 1s orbital on hydrogen with one of the sp2 orbitals on carbon. Alright, so you're left with that 1p. Where is this 1p orbital? If you, up until now, if you haven't kept up with this, if you didn't get this, hit pause again, go from here and figure out where the two 1p or the 2p orbitals go. Okay, you're back. The p orbitals are going to be orthogonal. All right. So if the 6 atoms in ethylene are all in the perpendicular to the plane of the board, like I'm showing here, then the p orbitals are in the plane of the board. Okay, so they're basically orthogonal to all these other bonds. And so this is going to give us 2 bonds. We have the sigma bond of the overlap of the sp2, so sp2 overlap, that's going to be our sigma bond. And then we have overlap of the pi orbitals. And again, it's hard to see this because, for clarity's sake, you keep the atoms kind of far apart. This is the reason the carbon-carbon double bond, or any double bond, is smaller, is to make that pi bond, the 2 atoms have to get closer together so that these 2 p orbitals can overlap. The p orbitals don't extend as far, right? This sp2 orbital sort of points well away from the carbon. So to get the 2 sp2 orbitals to overlap, you don't have to get the carbons all that close, relatively speaking. To get the 2 p orbitals close, you have to get them very close together. All right, so our pi bond is here, and that's just a pp overlap. All right, so you should acquaint yourself with the molecular orbital system here. We will use this in talking about reaction chemistry and to explain the rigidity of the carbon-carbon double bond.